All right, folks, this is a video to explain how you actually apply the definition of rotational inertia and then calculate an object's kinetic energy two different ways. So this is problem 22 from your textbook, and I'm going to pause it right there so you can write this down if you want. Please copy the picture. Please follow along. That is the whole point. So question number one says, find the moment of inertia about the x-axis and the rotational kinetic energy evaluated from 1/2 I omega squared. Okay, so giving me some more room. Hopefully this makes sense to you. I know since you're doing it from home and not in person, you can ask questions, but this red line, imagine this is your gummy bears stuck on a skewer and you are rotating it. See this gray arrow? You are rotating it back and forth, again, like the girls were doing with the juice boxes. So that's what's happening. You've got a 4-kilogram gummy bear, a 2-kilogram gummy bear, and a 3-kilogram gummy bear, and we're assuming that the skewer has negligible mass. Okay, so question number one is find I. And so that is the sum of mr squared. How many blobs do we have? We have 3. So we're going to have 3 terms. So we have 4 kilograms. The R is tricky. It is here listed at 3 meters. So they're being nice to you in that they're calling, the origin, the vertical origin is the axis of rotation. So we don't have to think too hard. But that blob is 3 meters away from the axle, and we're going to square it. And then we have 2 kilograms. That is 2 meters away. Again, that minus sign doesn't matter. It's just straight out how far away is it? Because the farther away it is, the faster it has to travel to get around once. It doesn't matter that it's -2. Okay, and then similarly 3 kilograms at 4 meters away. And so when you work through the math, you get 36 plus 8 plus 48, or 92 kilogram meters squared. Another awkward unit, you can just look at the formula to know what the units should be, but you need units in the end. Okay, so that is a measure of how hard that thing is to rotate. Question B was find the energy it would take to make those things rotate, because they're moving, so that takes energy. So instead of doing 1/2 mv squared, you're going to do 1/2 I omega squared. So I is 92, and omega they gave you, if you go back and look at the question, was 2 radians per second squared. That's another reason why radians need to be dimensionless. We need to be working in radians and not degrees, because so that's going to appear and disappear when we do problems, because it's just a ratio. It's kind of just a placeholder to remind us that this is a rate of change of angle. So anyway, a kilogram meter squared per second squared is a joule, and you get 184 joules. Okay, so that's how much energy it would take to get that set of gummy bears rotating at this speed. Okay, that was all question A so far. Question B is find the tangential speed of each particle, which I'll talk about in a second, and the total kinetic energy if you treat them as individual blobs. Okay, so I'm just going to draw this super quickly. Imagine we're rotating this towards you so that we're looking at a bird's eye view of these things rotating. Okay, so I will try to be very clear about this is the pivot. So now we're looking down on these as they rotate. And so what they're asking you to do is say, hey, you know what? This blob, we can look at this in aggregate. That's what we did in question A. Or we can say, look, this blob is going in a circle. So if I zoom out and think of this like a person on a track running around that track, they have a certain speed. This person here has, let's see, a speed that's a little bit faster because they are 3 meters away from the pivot instead of 2. And then this poor person on the very outer edge has an even faster speed because they are 4 meters away from the pivot. So every rotation, they have got to travel actually twice as far as the blue dude. Okay, so that's what we're going to do. We're going to pretend like instead of one solid object rotating, we have 3 individual things that just happen to be going at a circle at the same frequency. Okay, so I said I was going to address tangential speed. The reason they're calling it tangential speed, and I will try to be consistent, I do think that's a good term because that speed is tangent to the circle that the object is going in. Okay, so, and what is the tangential speed formula? It is omega times r. This is the formula that is just telling you omega is radians per second. So the faster everybody's rotating, clearly, the faster they're running. But the farther you are from the pivot, the faster you have to go to get around at the same time. Okay, so that is the formula for tangential speed. And omega was 2. So I know you can do this in your head. The speed of the 4, I'll do one of them for you. The speed of the 4 was 2 radians per second times 3 meters away. So again, the radian is just going to disappear because it's not really a unit, it's a ratio. So this object is, if you were tracking it through space and you had an odometer on it, it is going 6 meters per second. Similarly, V2 is going 4 meters per second, and V3 is going 2 times 4 or 8 meters per second. Okay, so that is how fast, if you were a drone zooming out, watching these people run in a track, that is how fast they're going. And then if we wanted to calculate their kinetic energy, we would have 3 terms of 1/2 mv squared. Okay, so the kinetic energy would be person, who is this? Person 4. This person, their mass and their speed combines to be 72 joules. This person has 16 joules. This person has 96 joules. So a total of 184 joules. So if you've been taking good notes, you will look up at what you've already written. It's the same answer that we got before. Okay, but this is the last warning. We're almost done with the video. The moral of the story is do not double count. Sorry, I'm running out of, I can't scroll anymore. Do not double count the energy. Don't say that the total kinetic energy is 184 plus 184. It's not. You're double counting the energy from 2 different perspectives. You either say, I have a solid object that's rotating, I'm going to count it that way, or I have 3 individual objects that are not really translating because they're going in a circle, that are running in circles. You're going to get the same thing. So do not double count the energy, only count it once. Okay? Hopefully that made sense, and it's kind of cool to show you that we're lazy, clever, and attractive. Do we want to add up the 3 different kinetic energy terms? No, let's only add up 1, 1/2 I omega squared. But the downside is that calculating I then was, you did still at some point have to deal with the fact that there were 3 individual objects. All right, that was it. Hope that made sense, and I will see you in class.